Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2018. Question number 7 is on the topic of forces. Figure 10 shows the horizontal forces acting on a man swimming in the sea. Describe the movement of the man when the resultant force is 0. When the resultant force is 0, two things can happen. Either he's stationary. Because he's already swimming, he should be moving at constant velocity. The man increases force A. Explain what happens to force B and to the movement of the man. Force A is the forward thrust, right? Now, B is drag. So if you increase the thrust, he is going to increase his speed, but that also means he increases the drag as well. So he would increase the speed first, then drag increases when both these forces are now equal. So let's say he increases this drag force by that amount. The drag force will increase to an equal amount, which means he will come to a new constant velocity or higher constant velocity. So the man will accelerate, so force B increases, right, which is drag, until force B equals force A. The man moves at a higher constant velocity. A boat moves along through the sea. There is 3000 Newton force to the west of the boat. There is 1000 Newton force to the south of the boat. Determine the magnitude and direction of the resultant force on the boat. Draw a vector diagram for these forces. So the boat is moving west at 3000 newtons, and there's a force of 1000 due south. So 1000 due south. So if I pick this point in here, 3000, let's say 1000, 2000, 3000. So if I draw a straight line, I'm starting here. 3000 newtons due west. 1000 is going to be 3 boxes down. I need to use the same scale on both sides. It should be slightly shorter. Let me redraw that. So you would need to label this as well, 1000 Newton. So you're going to get a mark for drawing 3 marks. So you're going to get a mark here for drawing an arrow due west and a vertical arrow pointing down. The resultant force should be, so let's complete this diagram. If I draw dotted lines, the resultant force is going to be pointing this direction. So the resultant force is from there to there. Now, how would you actually measure this resultant force? Now, question is, can you use Pythagoras theorem, which is, let's say this is going to be 3000. So A squared plus B squared is equal to C squared. So if that is A, B, and C. Let's see. 3000 squared plus 1000 squared. Find the answer. Find the square root of it. It will give me a value of for A. So 3000 squared is 9 million. But let me rewrite that. Plus 1000 times 1000 is a million. So add that to the 9,000, 9 million. Plus 9, 6, and find the square root of it. So square root of 10 million. The square root of 10 million is 3162.27 Newton. So you could use Pythagoras theorem, or you could actually use your ruler as well. If you use your ruler and measure, let's say they're usually 1 centimeter squares. So you've got 9 centimeters here, and if you use your ruler to measure this length, 9 centimeter, remember, is equal to 3000 Newton. So you can actually measure the length of this and then convert it into meters. As long as your answer is between 3100 and 3200, they will accept your answer. So I'm going to say 3162.0. Now the direction, you could say north southwest because it's going in this direction, but that's not going to be very accurate. So you have to be accurate. Here you would need a protractor. So this is 0 degrees. Using a protractor, that's 180 to the south, and you need to measure this angle, this entire angle, and that entire angle is between 251 degrees to 253 degrees. Right? So your answer is going to be 251 degrees clockwise from north the force to the south of the boat increases. If the force to the south of the boat increases, what effect does this have on the resultant force on the boat? Now, the magnitude, if this force increases to the south, let's say to 1500 Newton, what will happen? The boat will actually start moving towards the south. So the magnitude will actually increase towards the south, and the direction will change towards the south. 2 marks. The magnitude will increase, direction will change towards the south. That brings us to the end of this question. Thanks for watching. This is the first time I've actually seen where they have asked a question which is requiring to use a protractor in the physics paper. Right, I will see you in the next paper. Thanks for watching.